Hello and welcome to Yageo Group Design It Day Automotive. Today's topic is isolation requirements for onboard automotive electronics. My name is David Adib, and I am a senior technical marketing engineer here with Kemet in Florida, and I am going to be your host for today's presentation. The presenter today is Kevin Huang. Kevin is a senior application engineer at Silicon Labs. Before we start our presentation, I have some information for you. The duration of this presentation is 30 minutes and has been pre-recorded. If you have questions on anything you see, we want to hear from you. Please go to go.kemet.com/DID-contact to submit your questions. Please, if possible, note the slide number to which your question is related. We will follow up with your question directly after the event is over. Lastly, once Design It Day is over, you will receive via email a short survey. Your feedback helps us to improve our future events. With this information, I hand it over to Kevin. Hello, Kevin, and thank you for your time today. Please tell us a little bit about yourself before you begin your presentation, and then you can go ahead and start with your presentation. Thank you.
Thank you, David. Hello, everyone. My name is Kevin Huang. I've been working at Silicon Labs since 2004. I've been a senior application engineer for isolation products here in Austin, Texas for over 5 years. About today's agenda, we will start with giving you a general introduction about galvanic isolation, like what is isolation and the popular isolation technologies. I will show you a few automotive applications for isolation to give you an idea about how isolation products are used, since the most important feature of isolation is to ensure that user products are safe enough for human access interface. I will introduce the safety regulation, which is the way to ensure safety. In the last section, I will give you a brief introduction about the Silicon Labs product and several case studies. Let's start the first session with galvanic isolation overview. What is isolation? Galvanic isolation means no current flow, and the out signal faithfully represents in signal without lose valuable information, which means data pass through like it was zero impedance, and the input signal is transferred to the output. The output side is basically a very high impedance path from the input, and no current flow between ground 1 and ground 2. This is due to isolation barrier or dielectric between the input side and output side. The trick is to transfer electrical energy to enable signal transfer through optical, magnetic, or capacitive coupling method. Let's look at why isolation is necessary at all. The real world does not run on 3 volts always. High voltages are involved. Safety becomes important. Isolators block high voltages from one side to the other. Noise is always a problem. It might not be just high voltage transient causing noisy environment. It could also be you are making very sensitive measurements, and even small ground currents can disrupt these microvolt signals. Isolators eliminate almost all noise caused by ground loops because they literally cut the ground loop. Remember the low current flow characteristics of isolators. There are high voltage involved. Several circuits that need to talk to each other might not be referenced to the same ground. Signal transfer is a problem unless isolators are used. To summarize, isolators provide safety from high voltages, eliminate noise due to ground loops, enable communication between several circuits whose ground reference might be hundreds of voltage different. There are mainly three ways to couple signals across an isolation barrier without any current flow. Capacitive coupling digital isolators, inductive or magnetic coupling digital isolators, optical coupling optocouplers. Optos or photocouplers have been in use since the late 1960s. This is a default technology, and opto suppliers still have the big share of isolation market. However, digital isolators are rapidly gaining share. Basically, optos are slow. The part-to-part matching is poor. They have low noise immunity, and their operation over lifetime is not stable. The performance always drops when used in high ambient temperature environments. These are all the reasons that customers are switching to digital isolators. We won't spend a lot of time on this topic, but we would like to share a few important details about our isolation technology. This is the cross-section schematic of our isolators. It shows two silicon dies with high voltage capacitors in red and associated circuitry. The insulation is a layer of silicon dioxide. This layer acts as dielectric between the two plates of the capacitor. Silicon dioxide is a very good material for isolation because it is created as a fundamental step in semiconductor processing, and the production is highly controlled. That leads to no defects. This is important because isolation breakdown typically happens along a defect. No defect means long, reliable service life. It also has good dielectric strength, up to 10 times better than matures in competing devices. This method has a few distinct advantages. The construction of the product ensures it is highly reliable over a lifetime. It has low propagation delays, no skews, as well as excellent part-to-part matching due to the all CMOS process used. It also offers a very high noise immunity to voltage transition as high as 200 kV per microsecond, which is at least 2 times better than any product available today. These isolators are also much lower power compared to optos and even other digital isolators. All dielectrics are subject to aging. Reliability modeling is used to predict dielectric lifetimes. All dielectrics can be modeled using time-dependent dielectric breakdown methodology, we call TDDB. As a common practice for TDDB, as shown in the figure, the device under test is subject to high voltage and high temperature. We used maximum junction temperature, 150 degrees C, in a two-terminal configuration. TDDB accounts for temperature, electric field, and material properties. Various models have been studied, as you can see on the chart, some examples being the E model, the 1/E model, and others. Of these, the E model is the most widely used for silicon dioxide and is the most conservative one. Silicon Labs has extensive TDDB testing to prove long lifetimes. Silicon Labs products have the longest TDDB modeled lifetimes, even with using conservative E model. After the first session, galvanic isolation overview, we will show you a few automotive applications for isolation. As everyone knows, the electric vehicle market is quite hot and continues to grow. According to China National Info Center data, 79 million automotive was sold in 2018, and 108 million vehicles will be sold in 2025. According to JP Morgan forecast, by 2025, 30% of new vehicles will be electric or hybrid. Based on Bloomberg New Energy Forecast, by 2030, 28% of new vehicle sales will be plug-ins, BEV or PHEV. BEV and PHEV growth drive isolation needs. At least one electrified axial traction motor and plug-in capability onboard charger per electric vehicle. Higher performance vehicles have 2 electrified axles. FHEV has at least one electric axle. All brands produce hybrid electric vehicles. Right now, this increases demand for traction motors. For battery electric vehicle viewed as expensive, limited in range, and lacking fun to drive and comfort convenient features, as a compromise, 48-volt mild hybrid vehicles are developed and on the rise. Mild means 12-volt net plus 48-volt net with generator and plus internal combustion engine. It's more cost-effective than full battery electric vehicle. Mild hybrid vehicle is the largest emerging segment for electrification. It's a stepping stone to full electrification. There are two purposes to migrate from 12-volt mechanic to 48-volt electrical net. One is for drivetrain, starters, pumps, and generators. Another for comfort, AC compressors, heaters, and chassis stabilization. Mild hybrid systems need isolation. 12 and 48-volt must be galvanically separated from protection. Let's look at battery chargers for electrical vehicles. From a block diagram perspective, these are largely the same as the power supply. It is basically an AC to DC converter for precisely controlling the voltage and charge being applied to the battery. One of the main features is our low EMI. Automotive manufacturers have to pass stringent emission tests, and our isolation technology allows them to do that. Also, wide temperature range is important for these systems. Our gate driver SI8239 family can be used to drive the power stage and synchronize power FETs. The current sensor SI829X is used for power and fault monitoring. Most onboard chargers also have a communication system. This is a possible additional application with one of our digital isolation products like SiAA221. The high voltage battery in electric and hybrid electric vehicles is made up of lithium cells. As you might know, these require intensive monitoring for efficiency and safety reasons. Since the cells could be at different voltages, isolation is needed between cells and master control bus. Usually CAN bus is used. CAN stands for Controller Area Network. It was developed specifically for automotive use, but now it is being adopted by many industry designers. The SiAAX family is a great fit for isolating the CAN transceivers and to provide power to them. Dozens of global customers are using our isolation in BMS. We have technical application notes, evaluation board, and a user's guide for your reference. Motor drive traction inverter takes high voltage DC from battery and converts it to 3-phase AC 9 voltage to drive motor. Motor drive traction inverter works like a 3-phase DC to AC switching power supply. SI823X, SI828X, SI827X isolated gate driver here are used to drive power FETs to convert input DC voltage to output sine wave AC voltage with protection features like daytime control, desaturation detection, Miller clamp features, etc. The motor with wire windings, in fact, is a non-ideal inductor from electrical point of view. When we apply sine wave AC signal on it, the AC voltage and the AC current are not in phase, which makes visual power very high, but with less active power. The efficiency is poor. which also creates signal distortion to make motor spin not smoothly. The SI892X family is used to detect the AC line current and feeds back to controller to make the line AC current align with input AC voltage to reduce AC current signal distortion. The MCU controller in this diagram is used to speed, torque, position control, which needs to receive commands from main controller and send status back to it. The communication bus for case is CAN, which needs isolation. For this example, SI8X is used to CAN bus isolation. The most important feature of isolation is to ensure user products are safe enough for human access interface. The safety regulation is the way to ensure this. Countries regulate compliance via their country-specific system standards. UL is used for United States, CSA for Canada, IEC for international, CQC for China. European regulations are a little complicated. In general, the DKE under VDE is for Germany, and the CENELEC is for the rest of Europe. Component level certification regulated by component standards. Certified components are used to speed up system level approval to country standard like IEC 6950, IEC 61010, etc. Safety is regulated by a set of international safety standards whose test methods and guidelines ensure any equipment safety from electroshock, mechanical hazard, fire, and electromagnetic interference. Key safety terminology. If the voltage is lower than 30 volt RMS or 60 volt DC, we call it SELV or safety external voltage. Above 30 volt RMS or 60 volt DC is hazardous voltage, which is unsafe for human to touch. Basic insulation. Single level protection against shock does not feel safe, must be enclosed within the system and not accessible to humans. Reinforced double insulation. 2 levels of protection, like basic plus supplementary, feels safe and can be exposed to humans. Basic reinforced double insulation are the most common safety isolation requirement. For example, double insulation is required between SELV to hazardous live circuits. Safety standards for different types of insulation request different creepage and clearance distance. Creepage is the distance along the insulating surface. An arc might travel. Clearance is the shortest path through air an arc might travel. Rated isolation voltages. Safety standards define different rated isolation voltages. It can be maximum repetitive isolation voltage or VIO-RM, maximum transient isolation voltage or VIO-TM, maximum surge isolation voltage or VIO-SM, maximum working isolation voltage or VIO-WM. UL 1577 use dielectric isolation voltage rating is the maximum voltage for which an isolation barrier is independently qualified to withstand for 1 continuous minute, typically 2500 VRMS, 3750 VRMS, or 5000 VRMS. Lifetime working voltage or VIO-RM. Generally, it is derived from TDDB data based on multiple point line according to different lifetime prediction model, like the E model we are using. In this figure, we choose one working voltage from vertical axis and draw a line to find the lifetime. Every country has safety specifications that include requirements for isolation. There are specific system level standards for different types of equipment: telecom, industrial, medical, automotive, etc. There are also standards for isolation devices, optical couplers, silicon oxide-based isolators. Reinforced insulation rating is required for circuits that are exposed to human operators. Basic insulation is less stringent. We offer 2.5 kV and 5 kV products to support these two requirements. Different standards request different creepage distance and different clearance distance. In medical application, 8 mm creepage is requested for reinforced 250 VAC working voltage. As a rule of thumb, reinforced requirements are 2 times rows of basic. Agencies such as UL, CSA, CQC, and VD provide testing of end system and/or components. In some cases, components can also be tested to the system-level standards. As you might know, VD 084-10 is obsolete, and the -11 will be obsolete, and transition to the IEC 60747-17. Customers have to have their end equipment certified to the applicable system standard. However, using components with their own safety certificates can simplify system certification. Therefore, we certified all our isolation products in all the agencies listed above for customer convenience. In the next session, I will give you a brief introduction about Silicon Labs product and several case studies. Isolation technology can be incorporated into different product types. Digital isolators, as the name suggests, take in digital signals and transfer these to the output, like a buffer, but with isolation integrated. Isolated gate drivers take in digital signals and boost them to higher voltage rails and current drive capability. So they are used to control the switching of power devices like MOSFET and IGBTs. Isolated ADCs take in analog data and convert them into digital signal. Analog isolators take in analog data and retain the analog signal at the output while isolating it. We have all 4 types of isolator. The SiC-XX is our flagship isolation product. It's widely used in factory automation, battery management, process and motor control, PLCs, and control systems. The SiC-XX family can support up to 6 isolated digital channels, any configuration forward and reverse channels, output default no or high options, dedicated devices for isolating I2C. The SiC-XX family has been widely used for a long time with huge quantity shipment. The robustness has been proved by different markets. It can support 1, 2.5, 3.75, and 5 kVA isolation, up to 150 Mbps speed, low propagation delay. Simplifying isolation device power. Providing isolated power at a small level like 1 watt can be tricky. It can require many components and tuning of the control system. In many cases, the engineer for automation systems doesn't have experience with creating power systems. However, isolated power is necessary for having an isolated communication bus, so a more straightforward method is preferred. The SiC-XX solves this problem by providing the integrated DC-DC controller. With just a few external components, isolated communications and isolated power can be realized. This family can provide up to 5 watts of power, more than enough for the transformer, and can do that with good efficiency. It is the ideal solution for isolating S485 and CAN buses. The 4 types of power transistor we will discuss are silicon MOSFET, IGBT, silicon carbide, and gallium nitride. Silicon MOSFET is very popular, and they are good for moderate power requirements, moderate switching speeds, theoretical performance limit. Insulated gate bipolar transistor IGBT can handle higher voltage, more power, can be less expensive at higher power, a bit slower than MOSFET, but great for motor control. Silicon carbide can support high voltage, high current, and high temperature, very fast switching speeds. It's a driver that can handle fast transient. Gallium nitride can have high current, but not as high voltage as silicon carbide. Extremely fast switching, even faster transitions, narrow gate voltage range. The evolution of power switch technology has many implications for the isolated gate driver. Silicon MOSFET is very popular and a legacy power switch. Our Si-A23X and the Si-A239X family is a good fit for the MOSFET application, which can support up to 35 kV per microsecond SMTI. The family has a 4 amp driver capability and up to 24 volt driver voltage. It integrates dead time and overlap feature. It can support 5 kV RMS for 1 minute for reinforced insulation. IGBT power switch application. Faster switching speeds require higher peak gate driver currents in general, and these higher speeds combined with higher switching voltages drive up the SMTI requirements for the gate driver. Si-A2AX family is a good fit for the IGBT or silicon carbide application. As the power handling of switching devices increases, switch protection and the safety features such as under voltage knockout, Miller clamp, desaturation detection or overcurrent detection, and the soft shutdown become more and more important. Si-A2AX family has all the protection features and 100 kV per microsecond SMTI for IGBT and silicon carbide. Silicon carbide power switch application. Even higher working voltage, higher SMTI are necessary for silicon carbide power switch application. The newest Si-A23HX, Si-A252X family with 125 kV per microsecond is a good fit. It's an upgrade version of the Si-A23X family. It has symmetrical 4 amp output sink current and source current. It integrates thermal protection, 30 volt drive voltage for high gate voltage silicon carbide application. Gallium nitride power switch application. GaN needs the highest SMTI performance driver, narrow gate voltage window, no latency, and no skew for the highest switching frequency, like a 1 MHz switching frequency. Si-A27X family with up to 300 kV per microsecond SMTI is good for GaN application. Besides its excellent SMTI performance, the driver supply can support down to 3 volt for low gate voltage threshold GaN. The Si-A27X family has the best timing performance for the fast switching GaN. Besides device evaluation kits, we also provide different support resources like application notes, white papers, silicon guides, safety certifications, and so on. For more information, you can visit our webpage www.silabs.com/isolation to know the details.
Thank you for your presentation, Kevin, and thank you again, ladies and gentlemen, for joining us today. We hope you enjoyed this presentation, and we look forward to seeing you next time. Until then, We wish you the best. Have a good day and goodbye.